Okay, let's try this one more time. I think I got the microphone working. So it says the concentration of a drug T hours after being injected is given by C of T equals 0.2 T over T squared plus 70. Find the time when the concentration is at a maximum. Give your answer accurate to at least 2 decimal places. Okay. So I went to go ahead and graph this one, and it was kind of interesting because when I looked at my graphing calculator, it didn't show much. It just looked like the x-axis. When I did my did on Desmos, same thing. And when I zoomed in enough on Desmos, once I knew the final answer, it gave me the shape I was after here. So it's kind of like if you were to expand this out, the graph looks something like this. It went really along here, and I'm going to exaggerate it, and it kind of comes up and comes back down again. And so what we're after is this point here, this peak that it reaches. So there is no lowest value, but there is a highest value to this. And when it peaks out, it has a zero slope. And that's the key to this problem. This is one of the beauties of these optimization problems. We're able to apply what we learned about derivatives, because what does the derivative give us? It gives us the slope at any given point. And we want the slope here to be 0. So we put all these concepts together, and we have our C of t equals 0.2t over t squared plus 70. And then I'll do the derivative, c prime of t. So this, we're looking for m equals 0. So our derivative, I'm going to use the quotient rule, low d high minus high d low, all over the square of what's below. So it's going to be low, which is t squared plus 70. D high, or derivative of the high one, or the numerator, it's going to be 0.2 minus high, which is the 0.2t, d low, the derivative of what's in the denominator, so that's just going to be 2t, all over the square of what's below, so t squared plus 70, quantity squared. So, one thing to point out, that denominator, t squared plus 70, is never going to be 0 for real numbers, and we're dealing with real numbers here. And so squaring it's still never going to be 0. So we don't have to worry about any places that is undefined, so that doesn't really factor into any of our extreme values. So let's go ahead and look at that numerator. I'll just keep working with this. So it's 0.2 t squared plus 14 minus 0.4 t squared over t squared plus 70, quantity squared. So that's going to give us negative 0.2 t squared plus 14 all over t squared plus 70, quantity squared. And now if we just look at that numerator, negative 0.2 t squared plus 14, and set it equal to the slope we're after, and the desired slope is 0. Then we'd have negative 0.2 t squared equals negative 14 if I subtract 14 from both sides. Then we divide by negative 0.2, divide by negative 0.2, and we're at t squared equals 70. So t is going to be plus or minus the square root of 70, which is going to be approximately plus or minus the square root, don't need square root anymore, plus or minus 8.367, which is my memory of the answer, because I did it on my calculator, which is now charging. But the negative is not really helpful, so just the time is 8.367. So that means that this graph would be coming along here, peak out and go back down at 8.367. And that's it. Hope that helps.